get to the end of the first video, what we emphasized is that there's nothing that's said at all about sample means or anything to that effect, other than stating what the mean of the distribution is. And when I see something like that, I just use exactly what the standard deviation is, namely 13.1. But if you notice, letter B is very different. Letter B says, first off, it tells you how many women, 40 women from this population are randomly selected. And then it says their mean systolic blood pressure. In other words, the average of just those 40 women. Okay, that's what you're looking for. That question is like the blue box here. And there are some things that I want you to note here. The first is, look at what it says. The sample size, n equals 100. The sample mean ages, sample mean age. That's why we call this the central limit theorem of sample means, okay? You see sample mean age all over this question, and they give you a sample size. When that happens, you're still going to use normal CDF. It's still everything that you've been doing, but there's one big difference. The big difference is here in the green circle. You're going to have to take the standard deviation, which is 15, and you always divide by the square root of the sample size. In this case, it's 100. Yes, I could make that a 10, but I'm trying to emphasize that it's always the square root of the sample size, 100% of the time, okay? So the first big delineation is letter A, gray box. There's nothing about sample means. There's nothing about sample size, nothing at all about samples in here, other than to say that we have women in an age group of 18 to 24, and they have a standard deviation and a mean, but it's the mean of that population. In the blue box, very different. We have information about sample size. It says repeatedly sample mean, sample mean, sample mean. So that means we're going with the central limit theorem application, and when we get to the step, everything is the same, nothing changes, but when we get to the step for standard deviation entrance into normal CDF, I don't only put the standard deviation, which is 15 years. I have to divide that by the square root of n. Very, very, very important. That's when we put that formula up that says SE equals. That's the time and place to do that, okay? All right, my second concern is that you know exactly how to input certain phrases into normal CDF. For example, we could have, and we're going to consider the case, by the way, where a population has a mean of 90 and a standard deviation of 8. There are three possible probabilities that the question could ask for. The first is it'll say, well, what's the probability that it's less than a particular value? The second is, well, what's the probability it's between these two values? And the last is, what's the probability that it's greater than a particular value? So if they ask you for the probability that it's less than a value, you're still going to go to second var's normal CDF, but the first one is always the lower. And the lower in this case would be 0, because we can't get less than 0. And this wants a score less than 85. So 0 is the lowest score we can get. 85 is the highest score we can get. So whatever the lowest score goes in the first place, then 85 is the highest score. So you're going to go from 0 to 85. The mean and the standard deviation stay the same. You punch that through the calculator, it'll tell you 0.27. What if they say between two values? Like in this case, between 88 and 93. Well, again, second var's normal CDF. The lower value is 88. The upper value is 93. The mean is the same, it's 90. The standard deviation is the same, it's 8. You punch those numbers in, ba-bam, out pops 0.24. Life is good. What if they say that they want to know what's the probability that it's greater than a particular value? Like here, probability that the score is greater than 93. Again, it's second var's normal CDF. It's always second var's normal CDF. Question is, what do you put inside? Well, this one's greater than 93. So the smallest possible score is 93. 10 to the 99th is how we put the biggest possible number into the calculator, just like 0 is the smallest possible, usually. And then 90 and 8 stay the same. You punch that in and you get 0.35. So normal CDF, we can use it. If it starts talking about sample means, We must divide by the square root of n when we get to the standard deviation in the input stage. And when we talk about less than, it's from 0 to the number. When it's between two numbers, we put those two numbers in, and greater than is that number in high.